Hello everybody, welcome to this video. In this video we are going to take an actual MLP, multi-layer perceptron we'll take, right? And then we'll apply the process of back propagation and see how it works, right? So you don't worry about the calculations, because in this video there are so many calculations, right? But it's very important that you take your pen and pencil and then you write everything, because after that you will be making codes, right? But once you for one particular example you know all the things, right, what actually is happening for back propagation, then it's very helpful when you are um, finding some mistakes in your code or you are stuck somewhere, right? So let me just take a very simple MLP. So I have, this is my input layer, so I have two inputs. Okay, x1 and x2 are my inputs. So this is my input layer. Okay, I am giving values so that I can mathematically show you what is all about, like what are the numbers. Suppose my x1 is 0.05 and my x2 is 0.10, right? And then I have my one hidden layer. There is one hidden layer. So suppose this is hidden layer, right? So output here is, say, h1. Okay, so output here is h1. Okay, so basically, we have whenever we have a perceptron, we have a sum part, and one is your activation function, right? So I am denoting like this so that we have a clarity. Okay, so this is my hidden layer, right, having these two perceptron. So what will happen, and then let me just make my output layer with a different color. So suppose this is my output layer, so this is my output layer also will have the summation part and the activation part. And suppose there are two perceptron, again there can be more than two or one also even, right? So you have your x1 input here, x2 input here, and then you have your output y1 from here. Okay, y1, we call it as y1 final, and this from here you have your output y2 final. I'll tell you in a moment how this final thing is there. And suppose, because we already know corresponding to x1 and x2, this is your training data, so you already have your targets. You have this data with you. You wanted your t1 to be 0.01 and t2 be 0.99. So this is your expected outputs. Fine, I hope this is clear. So what we are doing here now, we have this is fully connected. So if it is fully connected, so we have this perceptron going into this as well as into this, right? And I told you how we will be defining weights, because this is the first layer. So I will have, it is going from 1 to 1, so 1 1 1, and this is going to 1 to 2, so 2, right? And I am giving these things numbers. So this is 0.15, this is my initialized weights. Okay, so how do I get it? Suppose there is some algorithm or randomly you have chosen them, you just assume that, right? And then you have your second, from second, here you will go, right, and here you will go. So here you will have your weights w, because you are going from 2 to 1. So again this is the first layer. So suppose w21 is your just a minute, this is your 0.20. Okay, so this is 0.20, this weight is 0.20, and here w22, and again this is first layer, so this is your 0.35 0.30. Okay, and then you also have a bias term, right? So suppose here my bias term is b1 equal to 0.35, okay, which is going into both the perceptrons. So I hope I am making sense. So now for the next layer, let us work in the similar manner. So from here to here, you can see from here to here, this is from first perceptron to first of the next layer. So this would be 1 1, and because we are working on the second, like from this was your first hidden layer and now you're going to the second layer, right? So I'll put a 2 as a superscript, right? And this value for this particular weight is 0.40, right? That is my initialized weight. And from here to here, this is, you are going from the first perceptron to the second perceptron. So this is 1 2 2, and suppose this weight is 0.50, and then you have from 2 to 1. Okay, so this is your W21, again the second layer, and this is 0.45, and from here to here you have W22, and that is also 2, and suppose this is 0.55, right? And suppose then I have a bias term B2 is equal to 0.60, which is going into both these perceptrons, right? And then you are getting your final outputs y1 and y2. Now let us see how you are getting your final outputs. So what will happen here, you will have, this is my hidden layer, right? So what will happen when your x1 and x2 will pass through this hidden layer? So let me call the output here is h1, and then it goes into the activation function. And the activation function we are using in this particular example, you know there are so many activation functions, right? I am using the sigmoid function as my activation function. And what is that sigmoid function? F of y is 1 over 1 plus e raised to power minus y, right? So this is my activation function. So what will happen when this x1 and this x1 here and this x2 will go in the summation part? So what will happen, we will have, and I'm calling the output as h1. So h1 is going to be the weight w111, right, times x1, okay, plus w then you have w21 1 times x2 plus there is a bias term. This is my h1. Then this h1 will go to the activation function, and I'm calling this as h1 final. Okay, that would be my my activation function operating on h1, which is actually 1 over 1 plus e raised to power minus h1. Okay, is that part clear? So this is my h1 final. So h1 final is coming out of here. Okay, so similar, if I actually calculate it, you can calculate it. So you can see that this weight is 0.15. Can you see here? So this is 0.15 into the value of x1, which is 0.05. Okay, and then you have your second weight, which is 0.20. Here you can see this weight 0.20, and then you have your x2 value, which is here 0.10. So you'll put it here, and then you have your bias term, which is 0.35. So you get the value of h1 as 0.3775. So h1 final would be your f of this h1. So that would be 1 over 1 plus e raised to power minus 0.3775. So you can use a calculator to find this thing. So it comes out to be 0.5933. Okay, so this is our h1 final. Now, so we know that what is coming out of here when we have all these numbers fixed. So you have to bear with me because the calculations are so many, right? But just keep in your mind that you have to just go through once, like, okay, from all these calculations, because they are, you don't have to perform these calculations again and again every time you are working on your MLP, but it will be definitely helpful if you know the inside out of what is happening in the back propagation. Right, now let us come to your h2. Now h2 is here h2 is coming, then it is going inside activation function, and I am getting my h2 final. My activation function is same everywhere. Now you see here what you are inputting this x1 and x2, right? So we have h2 would be the weights from 1 to 2 x1 plus weights 2 to x2 plus again you have the same bias term b1. Now you note all the numbers. You have this weight as 0.25 here, and this value of x1 is 0.05, and then you have your second weight which is 0.30 and value of x2 which is 0.10 plus 0.35. So you get your h2 as 0.3925. Okay, so this is your h2. So what happens now, the moment you have h2, h2 will go into the corresponding activation function. So you will have your h2 final. So what is your h2 final? h2 final is the activation function operating on h2. So that is 1 over 1 plus e raised to power minus h2. So that is 1 over 1 plus e raised to power minus 0.3925, and it comes out to be 0.5969. Okay, right. Now what is your next task? Now you want to know what comes out of here, y1, and then that will go to your activation, and then you'll get your y1 final. Similarly, you want to know what is coming out of here, which is y2. Then y2 is going inside your activation function, and you are getting your y2 final. Right. So let us see what is my y1. So you can see that what is being fed into y1. Here you see h1 final is going from here and h2 final is going from here. So you have to choose your weights accordingly. So we have 1 going to 1, but the second layer this time h1 final, right, plus the second your second weight which is w 1 2, right. So 2 1, from 2 to 1 we have to go, h2 final plus your bias term, right. Now if you put all of them, this is 0.40. Now you see what was your h1 final here, 0.5933, 0.5933, and then you have this weight as 0.45, and this value is 0.5969, plus your b2 is 0.60. That was your bias term for the second layer. So this comes out to be 1.1059. Okay, so this is my y1. So what is my y1 final? That would be, you see, the moment you have your y1 here, so y1 final will be just the activation function operating on y1. So this is going to be f of y1. So that would be 1 over 1 plus e raised to power minus y1. So that would be, you can just put the value 1 plus e raised to power minus 1.1059, and so that value is 0.7514. Okay. Similarly, you can go for y2. y2 is again, if you just, what is being fed into by y2, that is again h1 final and h2 final. So you have the weight 1 going into 2, right, 1 going into 2, 1 going into 2, okay, and then the second layer, and then h1 final, and for the second one you have 2 going into 2 and the second layer, and h2 final, and then you have your bias term which is b2. If you put all of it, so you will get, now you see what is your weight here for the first thing, right. If you see your weight, that is your 0.50, and what is your h1 final, that was your 0.5933. Okay, and for the next one, what was your weight? It is 0.55, and what is your h2 final? This is 0.5969, and then your weight is 0.60. So this is 1.225. Okay, so now you have your y2 final, that would be 1 over 1 plus e raised to power minus y2. So that is 1 over 1 plus e raised to power minus 1.225, and that comes out to be 0.7729. Right. Now you see we have our y1 and y2. So what is our y1 here? What we got, that this value is 0.7514, and this value here is 0.7729. Now you see what we were expecting. These are the values we are getting, and these are the values you were expecting. So you are far away from the values, right? So what we will say, okay, so we have this situation that we get y1 is equal to 0.714, and y2 equal to 0.7729, and we were expecting t1 to be 0.01 and t2 to be 0.99. So this process is called a forward step, because what you have done, you have just gone from left hand side to right hand side, right? A forward step. So what this step is going to give you, you can actually have an estimate of error, right? An estimate of error. Now the question is how you are going to estimate errors. So this something we call something we have which is called cost function, which is nothing but error. And how do you measure error? There can be simple things like mean square error. Okay, mean square error, which is nothing but we are going to do half of your y1 minus t1 square, y1 final actually, right? And then you have your y2 final minus t2 square, right? So you can have this as your mean square error. But I just want to mention that there are other ways to measure your error. For example, you can have cross entropy. We'll discuss in the later videos what is exactly cross entropy, right? So depending on what is the complexity, but mean square error does a pretty good job, so we don't have to worry about anything, right? So now we have this is as our error, right? And we got this error from the forward step, right? So what error I get here, I get this error if I just put all the values, 0.01 minus 0.7514 square plus 1 by 2 times 0.99 minus 0.7729 square, and this error is 0.2984. So this is the error I got, right? Now what I have to do? I have to minimize this error. I want to reduce this error. Okay, so what is in my hands? For that, I will update my weights. Okay, so how to update the weights? I will use the back propagation. I will use the back propagation, right? So that we are going to do in the next video, that how we are going to update our weights. Thank you for watching. Keep sharing this video. Thank you.